Generally, a thin film of oil or soap appeared colored due to interference of light from the reflected as well as transmitted system. The thin film of oil or soap has two surfaces, the top and the bottom surfaces. The incident monochromatic light suffers reflection and refraction from the top surfaces and transmission from the bottom surfaces. Let us suppose a monochromatic light S from the source is incident in the upper surface of the thin film of refractive index mu at P1. As it gets incident, it suffers partially reflection along P1 R1 and partially refraction along P1 C1. Again, as soon as it incident in the C1 surface, it get partially reflection along P and partially transmitted along T1. Similar condition, when it incident at P, it get partially reflection along C2 and partially refraction along R1, and this continues. Let us suppose the path difference between the lights. As the incident ray incident in the surfaces, there is some path differences between the surfaces. Let us calculate the path surface. Path difference between the light is equal to path difference between P1, C1, P2 in medium minus path difference between P1A in air. And after calculating this, we got the result as the path difference comes to 2 mu t cos r, where t is the thickness of the film, mu is the refractive index of the film, and r is the angle of reflection. Now, according to Stokes' law, if a ray P1R1 suffer a reflection at the surfaces of the denser medium undergoes a plane change of pi, means the phase difference of pi is equivalent in the surfaces, as well as the path difference equal to pi. Then from the similar condition of formula of phase difference and path difference, we can calculate the phase difference, and that comes lambda by 2, where lambda is the wavelength of the light. At point C1, the reflection takes place with the ray P1, P2 is going from denser to rarer medium. Hence, the effective path difference between P1R1 and P2R2 is lambda by 2, means 2 mu t cos r minus lambda by 2. As well as we considered the thin film appeared dark and bright due to interference at the reflected system, as well as the interference at the transmitted system. As we talk about reflected system, the ray P1R1 and PR2 are the reflected systems, means the ray which get incident from the upper surfaces of the film, this is called as reflected system of the film, and which is transmitted from the down, means the bottom surface of the film, is known as transmitted system of the film. As both the reflected systems and the transmitted system play a vital role in appearing a thin film colored, means the colored of the thin film is due to the reflection or interference from the dark and bright film. So as we calculated the path difference as well as phase difference, let us come the condition of constructive interference in the thin film. We know that the constructive interference, the path difference should be integral multiple of lambda, means the path difference, that is 2 mu t cos r minus lambda by 2, is equal to integral multiple of lambda, where n is the whole numbers, means 2 mu t cos r is equal to 2n plus 1 lambda by 2. This is the condition that satisfies the film to appear bright in the reflected system. Similarly, for destructive interference, the path difference should be odd multiple of lambda by 2, means 2 mu t cos r minus lambda by 2 is equal to 2n minus 1 lambda by 2, which is equal to 2 mu t cos r is equal to n lambda, which is the similar condition of film to appear dark in the reflected system. Now let us see what is the interference in the transmitted rays. The transmitted rays C1 T1 and C2 T2 appears a transmitted system. Let C2b is perpendicular drawn to C2 to C1 T1. Here it has been sent C2D C1 T1. After drawing a perpendicular, we got a path difference of 2t 10r sin I, This is the value of the path difference that we got. After evaluating it, we got the similar path difference as we got in the reflected system, that is 2 mu t cos r. Now the similar condition also appear here for the constructive and destructive interference. Hope it is clear to all of you. Thank you.